Hello friends, welcome back to my YouTube channel. So in this video we'll start the new chapter. Its name Cable Suspension Bridges. So first of all we'll see the each and every component of this. So this is the cable diagram. So here between in these two towers it's called the suspension cable. So it's called the suspension cable. It lies in between two towers, and here it's called the anchor cable. It's present on both sides. It's called anchor cable, and this is called the decking where vehicles, this is the part where vehicles used to move. It's called decking. And these are called the suspenders. The place which is holding suspension cable and decking together, it's called the suspender. Though this cable is on tension on both sides because this suspender cable pulls it towards upside and this decking pulls it towards downside. Because of this cable is in tension. So when we move towards the center, here you can see here, when we move center and we get the minimum tension. So but when we move away from the center, we'll get the maximum tension at the corner. So tension at middle is minimum. So when it comes to corner, our tension will be maximum at corner side. So our tension is maximum. Our tension is maximum on corners, and its tension is minimum on center. Here is the span length, that is capital L. Span length, capital L. So and from here to here is the dip, that is small d. Here to here is dip, small d. So distance between here to here is small d. We'll get two types of supports here, so we'll see one by one. So first will be pulley. So the diagram of this will come like this. It will come like this. Here cable, here also one cable. It's called suspension cable, and one more is anchor cable. So I will shortly write it as AC. It means anchor cable, and SC means suspension cable. So another is roller support. So the diagram of this will come. Roller means it will have roller support like this, and this is our cable. Here also it's called anchor cable and suspension cable. So now we'll see the what is the difference between pulley support and roller support. So in case of pulley support, the puller is fixed at one place. Pulley doesn't move, so which helps to move this cable. So puller is fixed at one place, it does not move. So with the help of this puller, this cable will move either left side or right side. It will move both the side. So our pulley does not move, it is fixed at one place. In case of roller, what happens? The support is not fixed. It will move with the help of this cable. When the cable moves, the roller support is also moves. So I will explain what is the difference between these two. I will show you with the help of. So assume it's our pulley. So on this, so it is fixed, it does not move. So this is our cable. So this is our cable. This cable will, this is assumed as its cable. So with the help of this support, it will move like this, either left side or right side. So when it moves, when this cable moves, the pulley doesn't move. So because of this cable, the generation of tension on both sides will be equal. It can move like this. But when it moves, so when it moves like this, our cable doesn't move. So because of this, the generation of tension on both side will be same. So when it comes to roller support, our assume it's a roller support, this is not fixed. So with the help of this, when our roller support moves, our cable also moves like this. It also moves like this, either left side or right side, because this support is not fixed. The roller support, as it moves, so as our support moves, our cable will also move with it. It is not fixed like this. But in case of pulley, our support is fixed. Only the cable will move like this, either left side or right side. Only the cable moves, our support is not moves in case of pulley support. But when it comes to roller, our roller support is not fixed. As our roller support moves, our cable also moves like this, like this. It will move like this. So because of this, the generation of tension on roller side will be different. So here on pulley support, generation of the tension on both sides will be same. So I will show now. In case of this, our generation of tension on both sides will be same. T, call it as T and T. So in case of roller support, the generation of tension will be different. So now it is call it as the here T1 tension, here call it as the T. So because of the movement of the roller movement, as cable moves, the generation of the tension on both sides will be different. The tension will not same here. Here call it as T1, here T. So when it comes to pulley support, the generation of tension on both sides will be same. So now if you want to calculate the tension, so we couldn't calculate this directly because this is on certain angle, so it needs vertical and as well as horizontal component. So if you draw the normal line here, this side angle called theta and this side angle called alpha. Because two angles are different, that's why I'm calling it as theta and this as alpha. So which has angle that has cos term and which doesn't has that has sin term. So cos term means T1 T, not T1 T cos theta and here T sin theta. So same goes here, which has the angle that is cos term, that is nothing but T cos alpha, because this angle is alpha, and here T sin alpha. So when it comes to this roller support, again if you draw the normal line here, so both angles are different, so that one I am calling it as theta, one angle I am calling it as alpha. So again same, which has the angle that has cos term and which doesn't has that has sin term. So theta means T1 here, T1 here, the both the generation of tension will be different here in case of roller, so that T1 cos theta and T1 sin theta. So here also which has the angle that is cos term, T cos alpha and T sin alpha. So here tension are different because in case of roller, the formation of generation of tension will be different. So now if we see the formula, first we'll see for the pulley support. So we'll see now vertical. So we'll see the vertical forces. So for pulley support we have the vertical means here T sin theta and C T sin theta and T sin alpha. These are the vertical forces, so that our formula will be, so T in both the side T is common, so T is same, so I will write it, later I will take it as common, plus T sin alpha. So T is same, I am taking common, sin theta plus sin alpha. This is the formula for vertical. Now we'll see for horizontal. The horizontal forces are T cos theta as well as T cos alpha. These two are the horizontal. So T cos theta minus T cos alpha. So I am taking minus because you have to take one side negative. If you are taking right side positive, then take left side negative because both are in opposite direction. So I am taking T cos theta minus T cos alpha. So again here T is common, so T, I take T outside, remaining is cos theta minus cos alpha. This is the formula for horizontal. Now we will see for the roller support. For roller support only vertical will come always, because the horizontal load will not exist, because horizontal load will get cancelled with each other. In case of roller only vertical load will come. So what are the vertical loads here? Vertical loads are T1 sin theta and T sin alpha. So T1 sin theta plus T sin alpha. So this is the formula for vertical in case of roller. So here horizontal force will not exist because our roller is frictionless. We should not consider horizontal load, it will get cancelled with each other. Here also bending moment will not occur at top. So and our roller never has the horizontal load. So these are the formula for calculating the pulley support as well as roller support. So in case of pulley, we'll get the both vertical and horizontal. So vertical process are, here the vertical is T sin theta and T sin alpha. These two are the vertical forces, and horizontal forces are T cos theta and T cos alpha. So I have taken, and in both T is common in both sides, so I have taken T outside, remaining is this. And in case of roller only vertical force will exist because horizontal will get cancelled with each other. So here the vertical forces are T1 sin theta as well as T sin alpha. So I have written here. So I will tell you one more thing here. So this is point A, call it as this is point B. So reaction at B, so RB will come here, reaction at point A, reaction at A, RA will takes place. So here also horizontal load will come, so it always act outward, so H value here also on both sides will be same, it also act outward. So why it's act outward means I will tell you. So this is our arch will be in this direction. So if we applied the load on top here on center, what happens if you apply the load like this? It will go like this, it will go outward, like this. So our arch will be like this. When we apply load, it will both will go like this, outward, like this, outward it will go. So when it go outward, so our H will be inward in case of arch. So in case of our cable diagram will be like this. So when we applied the load at bottom here, what happens? It will come inward like this, it will come like this. So because of this, our horizontal load always act outward in case of cable. So that's why In case of cable, our H always act outward. So I hope you all understood. So here one more thing I will explain you. So here RA and RB value will be same because it is symmetrical arch, and our H value will be also same because it's symmetrical. So I will give you one more formula. So that is our T maximum. So it will come here like this. T maximum here also. T maximum always will be at the corner of this. So for calculating the T maximum we have one formula, that is RA square plus H square. RA square plus H square. This is the formula calculating the T maximum. So here our T minimum always it comes at center. So T minimum formula is equal to H. So our H value is always equal to the T minimum. So these are the formula for calculating the T maximum as well as T minimum. These two will require while solving the problem. Will require RA and RB value will be same. What's our RA value? That will be our RB value, and our T minimum value will be equal to the H always. So this is the formula we required while calculating the problem, while solving the problem will require. So I hope you all are understood. So if you like the video, like it, share it, and subscribe for the more videos. Thank you for watching.